Hello, this is Chapter 18, Question 33. This is Part 2. I did Part A. We analyzed, or we looked over the data, and I explained everything. We made the stamp plot in Part A. Now we're going to do Part B. We're going to do two hypothesis tests, one with the outlier and one without the outlier. Um, One quick change, though, from the first part. It says, I didn't notice this before, but it says they want to do the control limb minus the experimental limb. So when I did the subtraction, I subtracted the other way. So let's just take a moment here. Back to our Excel sheet here. Um, let's just to avoid confusion, let's do it the same way that they want us to do in the book. So we'll do control minus the experiment. Okay, so no big deal. The numbers are the same. I just need to do C2 minus B2 instead. So C2 minus B2. So I get a positive 8 instead of a negative 8. And let's copy that down. So all the numbers stay the same except I've got mostly positives instead of mostly negatives. And I think the reason the author wanted to do control minus experiment, it doesn't really matter which way you do it. In fact, most of the time people do experiment minus control. But I think the reason the author wants control minus experiment is so we have mostly positive numbers. Positive numbers is just a little bit easier to work with. So that means that this is going to change here. So a negative now means that the control is lower, and a positive means that that the experimental group is lower instead. All right. So let's go back to the to answer the question now. So part B, it says a good way to judge the effect of an outlier is to do the analysis twice, once with the outlier, once without. Okay, carry out two t-tests, in other words, two hypothesis tests using the t-distribution to see if the mean, and this is the important part here, to see if the mean healing rate is significantly lower in the experimental limbs, one with all 12 newts and one that omits the outlier. Okay, so let's write up our null and alternate hypotheses here. So we want to know if the rate is lower in the experimental limb. So I talked about here a positive means the experimental limb is lower. So we're hoping for positive numbers here when you subtract. Now, if we had done experiment minus control, I'd be hoping for negative numbers. But I'm hoping the experimental ones are lower, and they are. So that means positive numbers. So for my null and alternate here, let's just get a new sheet here. We're done with this stuff here. All right, so this is 18.33 part B. All right, so the null hypothesis is mu equals 0. That's always the case with matched pairs, meaning there's no difference between the experimental limb and the control limb. Okay, the alternate is mu is greater than 0 because the question says, is the experimental limb lower? And back to our spreadsheet here, since I'm subtracting the experimental limb from the control, if the experimental limb is lower, then I'm getting positive numbers, which is the case. So it looks like, yes, there's going to be evidence to reject the null here because it's quite a lot of positives here. The mean is most likely going to be positive. But anyway, back to here. There's our null alternate. That's step one. Now, what's alpha going to be? It doesn't say. It just says, is there a significant difference? Let's just do the standard 0.05 here. Okay, step two, we need the mean and the standard deviation and the n and degrees of freedom. We have to do this twice. Once with the outlier and once without. So let's just make two sets here and just so this is without the outlier. Okay. So let's just have Excel do this for us. So I want the average here of cells D, remember, it's just the differences now. I don't need anything else. So the average of D2 to D13. Okay, so that's 6.416. That's the mean with the outlier. Okay, standard deviation of D2 to D13. Standard deviation with the outlier. Okay, now, all right, let's copy those down here. So mean, let's just do 6.417. That's probably good enough there. 6.417. The standard deviation, 10.706. Okay, n equals 12 when we have our outlier. Degrees of freedom is 11. Okay, without the outlier, so all we have to do here, go back to our Excel sheet. Let's just delete this outlier. Just select it, hit the delete key, and in Excel, everything's automatically recomputed. So now this is the mean without the outlier, and the standard deviation without the outlier. Okay, so big difference, 4.182. So that one super newt who has 31 micrometers per hour faster with the control limb here, he or she really made a big difference in the mean, and the standard deviation as well. Let's go back here. The standard deviation is 7.756. Okay, 7.756. All right, now, by the way, the sample size changes as well. Since we threw out the outlier, we only have 11 in our sample, and our degrees of freedom is 10. All right, so part 3, do the analysis.